Good afternoon everyone, my name is Sahil and today we are going to discuss about some MCQs of electrostatic chapter. And here's our first question. In this question, the acceleration of an electron due to mutual attraction between electron and a proton when they are 1.6 meter apart. So here in this question, acceleration needs to be found. It is asking about acceleration. We have to find the acceleration. What's given? The distance between the charges, that is 1.6 Armstrong. We know that 1 Armstrong is equals to 10 raised to power minus 10 meter, and so the distance will become 1.6 into 10 raised to power minus 10 meter. Okay. Now if we move further, to find the acceleration, first we will need to find the force. So the formula of force here is F is equal, so we know that in electrostatic force is equal to 1 by 4 pi epsilon naught Q1 Q2 upon R square. And what is Q1 Q2? Charges here. One charge is electron and another is proton. We know that the value of charge for both these things is same, just signs are opposite. So the charges will become, for both Q1 charge is E and Q2 charge is E. So here it will become E square by R square. And we know that 1 by 4 pi epsilon naught value is also given here. 9 into 10 raised to power 9. And the value of E is also given, 1.6 into 10 raised to power minus 19 coulomb. We'll take the square here. And the value of R is also, we have found 1.6 into 10 raised to power minus 10. We'll take square here also. You can see here 1.6 whole square is also in numerator and denominator, so we can cancel out this. Now what we will left with? We left with 9 into 10 raised to power 9 into 10 raised to power minus 19 square divided by 10 raised to power minus 10 square. So it will become 9 into 10 raised to power 9 into 10 raised to power minus 38 divided by 10 raised to power minus 20. So if we solve the values of bases here, 10 bases, so it will become 9 minus 38 plus 20, and so that will be 18, 9. So 10 raised to power minus 9. So the force here is 9 into 10 raised to power minus 9 Newton. Now we have to find the acceleration. We know that from Newton's law, force is equal to mass into acceleration. And whose mass we are talking about? We are talking about mass of electron. And the force value is this. Now we have to find the acceleration, so we will divide the mass on the other hand side, and the value of mass is 9 into 10 raised to power minus 31. So we'll put the value here. 9 and 9 will get cancelled, and the value of acceleration will be 10 to the power minus 9 plus 31. So that will be 10 raised to power 22. So you can see the option C here is the right answer for the acceleration. Okay, I hope you understood this. Now we'll move further to the question number 2, and the question is asking about, suppose the charges of proton and electron differ slightly. One of them is minus E and other is E plus delta E. We know that we'll take here, so two charges are given. We'll take one charge as minus E and another charge as E plus delta E. Okay, if the net electrostatic force and gravitational force between two hydrogen atoms placed at distance d apart is 0. So you can see here it is talking about two hydrogen atoms. That means two charges are almost same. So if we take the net charge in hydrogen atom, so that will come out as E plus delta E minus E. So E and E will get cancelled. So delta E will be the net charge between hydrogen atoms. And now second thing, Here we have given the net force, electrostatic force and gravitational force between hydrogen atom placed at distance d is 0. As you know, if there are two hydrogen atoms, let's suppose this and this, there will be some gravitational force between them also. There is also electrostatic force between them also. But we know that the electrostatic force is much greater than the gravitational force. So electrostatic force is much greater than the gravitational force. So what will happen if we take the, here it is given the net force is 0. So the sum of these forces must be 0. Okay. So if we take the net, so the force of electrostatic minus force of gravitational will be 0. Now we know that the force of electrostatic is given by kq1 q2 upon r square, and force of gravitation is given by g m1 m2 upon r square. Here both r square are the distance, m1 m2 are the masses, and q1 q2 are the charges here. So if we put these values here, so the force of electrostatic is given by k. Now charges, we know that the net charge is q, delta q here, so it will be delta q square upon r square. Here distance is not r, distance is d, so we'll take d here, d square. And if we talk about force of gravitation comes out g m. Now we'll take the masses of both the atoms. As we know, both the atoms are hydrogen atoms. We'll write here mass of hydrogen atom square, because both the masses are same here. Now we'll solve further. We'll take this to another side, so it will become k delta E square is equals to g mh square upon d square d square. So d square will get cancelled, and we'll left with k delta E square is equals to g mh square. Now we'll solve it and find the value. We have to find the value of delta E here. Okay, so to find the value of delta E, we'll move other terms to another side. So it will become delta E square is equals to g mh square upon k. So by putting the value, we get the value of delta E as 1.43 into 10 raised to power minus 37 coulomb. Okay, so we can see here it is approximately equal to the option C. So our option C is the right answer. I hope you understood this. We'll just put here the values. I haven't done that. You can do that. Here the value of G, the gravitational constant, is 6.67 into 10 raised to power minus 11. And the value of K, we know that 9 into 10 raised to power 9. And the value of MH is given here. So you will put the values and you will get this answer. Okay. So now if we move further, here's another question. When air is replaced by a dielectric medium of constant K, the maximum force of attraction between two charges separated by a distance. So if there is a force of attraction between two charges, let's suppose there are two charges plus and negative, Q1 and Q2. And if there is air between them, the medium between them is air. So the force of attraction will be given as 1 by 4 pi epsilon naught Q1 Q2 upon R square. So here is the force of attraction when air is present there. But if we take in place of air, if we take another medium, let's suppose dielectric, here it is given dielectric. So we'll take the dielectric medium, then the force will become 1 by 4 pi epsilon naught, not epsilon naught, it will be epsilon Q1 Q2 upon R square. So here you can see the only difference between this is the permittivity here, because in the air the permittivity is epsilon naught and in the dielectric it is epsilon. We know that the epsilon and epsilon naught relation, the ratio of epsilon and epsilon naught is equals to dielectric constant. If we here we take the value of epsilon, so it will be K into epsilon naught. and we put the value in this dielectric equation, so it will become 1 by 4 pi epsilon naught into K Q1 Q2 upon R square. Now if we take the ratio of force in air to force in dielectric, we'll get 1 by 4 pi epsilon naught Q1 Q2 upon R square divided by 1 by 4 pi epsilon naught into K Q1 Q2 upon R square. So you will see here everything will get cancel out, here, this and this. So we'll only left with 1 upon 1 by K, that is K. Okay, so this equation will become equal to K. So here you can see that the force in air is K times force in dielectric. So that means if we move from air to dielectric, the force will get decrease. And how many times it decrease? K times. The force will decrease by K times. That means option A will be the right answer, because it decreases K times. It does not increases K times. It does not remain changed or become 1 by K square. It becomes K times, decreases. Okay. So I hope you got the answer. Now we will move further. Here's another question. A charge Q is placed at the center of line joining two exactly equal positive charges. So here's a line joining two positive charges Q and Q. At the center there is another charge, that is Q. These charges are positive obviously, and the system of three charges will be in equilibrium. So for the equilibrium, you know the condition that in the equilibrium, the net charge will always be equal to 0. Okay. So if the net charge is 0, we can find here how to find it. We'll just find the force first. Okay. The net force on the charge will be also 0 if charge is 0, and the force will also be 0. How can we find it? We'll find it using force formula. The force is 1 by 4 pi epsilon naught. Now in which charges we'll find the force? We'll first find the force between these two charges. So the force will be Q small q by, let's suppose this distance is r, so r square. So this distance is r, so this distance will also be r. Okay. So the first force is 1 by 4 pi epsilon naught Q by r square. Now if we take the second force, now we'll take the second force between this and this charge. By this and this charge, because if we take force between this and this charge, that will become another first case, you can see here. So the answer will be same. Now we will take the effect on this charge by this charge. So what are the forces they are applying on each other? Okay. So that will also become 1 by 4 pi epsilon naught. Here it will become Q square by r square. Here distance between them is not r, it's 2r. If we look closely, the distance between them is r plus r, that will be 2r. Okay. So it is 2r square. Now the net force will be equal to 0. So how can we find it? We'll just add these two forces. Okay. And equal to 0. They will become equal to 0. So the net force is F1 plus F2. So 1 by 4 pi epsilon naught QQ upon R square plus 1 by 4 pi epsilon naught Q square by R square will be equal to 0, as net force will be equal to 0 for equilibrium. Now if we move one of these equation to another side, it will become 1 by 4 pi epsilon naught QQ by R square is equals to minus 1 by 4 pi epsilon naught Q square by R square. Now this and this will get cancelled out. Here it is 2r square. So r square and r square will get cancelled out, and 1 of q will also get cancelled out. So the value of small q will be equal to minus of q upon square of 2, that will be 4. So the value of small q which is being asked is minus q by 4. So option A is the right answer. I hope you understood. Okay, so here there is only one condition being used here, that is the net force in equilibrium on the charges is 0. So we have used that condition to find the value of small q. So the value of small q is minus q by 4. Now if we move further, here's another question which is asking point charges plus q, 4q, minus q and plus 4q are kept on the x-axis at some distances. I think it's almost similar question to the previous one, just with the modification here. 4q, here it is also 4q, at the center it is minus q. Now we have given all the values of q's, and the point here is x is equals to 0, it's x is equals to a, so x is equals to 2a. So you can see the difference between these two is a, and the difference between these two is also a. Now what is asking, these conditions are respectively then, okay, we are only, first condition is only minus q is in stable position, none of these charges are in equilibrium, all the charges are in unstable equilibrium, all the charges are equilibrium. So first we have to find the equilibrium of these charges. How can we find out? We'll use the condition again. Okay, first we'll find the force between these two charges, then these two charges, then these two charges. So then we net this out. Okay, so here what is the force? First one, the force between first one is 1 by 4 pi epsilon naught and plus 4q and minus q. So these are our two charges and the distance between them is a square. So here's our F1. So what will be the F2? F2 will be force between this and this charge. So it will be 1 by 4 pi epsilon naught plus 4q upon a square or 2a square. Here the distance between these two is 2a square. So we'll take 2a square. Now we know again the condition of equilibrium, the net force will always be 0. So if we take the sum of these two, that should become 0, so that charges are in equilibrium. Okay, so if we take the sum of these two, it will become 1 by 4 pi epsilon naught minus of 4q square upon a square, that is F1, and the value of F2 is plus 1 by 4 pi epsilon naught 16q square upon 4a square. So if we cancel this out, it will become 4q square. As you can see, these two are almost similar, so the answer will become 0 here. So if the answer is 0, that means these all three are in equilibrium. Okay, so the first and second condition got cancel out. So now we are only left with C and D. These are in equilibrium, but we don't know whether they are in stable equilibrium or unstable equilibrium. To find out whether they are in stable or unstable equilibrium, what we'll do, we'll just try to see here. Let's suppose if I move this central charge towards this side, whether they will remain in equilibrium? No. Why? Because the distance will change, and if the distance will change, the net will not become 0. Okay, so that means this is not a stable equilibrium, this is a unstable equilibrium. So option C is the right answer. I hope you got the last part. Now we'll move further to another question. A spherical conductor of radius 10 cm has a charge 3.2 into 10 to power minus 7 distributed uniformly. What is the magnitude of electric field at the point 15? So what we have given charge 3.2 into 10 to power minus 7 coulomb, and we also have given the radius, that is 10 centimeter. We also have given the point where we want to, let's suppose it's x, so that is 15 centimeter. We know that we can't take it in centimeter, we have to convert it into meter. So 15 into 10 to power minus 2. So here's our point. Now we have to find the electric field. So for the electric field, what is the formula of electric field? 1 by 4 pi epsilon naught Q. Q is 3.2 into 10 raised to power minus 7 by r square, or the distance square. Here the distance is this. So 15 into 10 raised to power minus 2. and the value of 1 by 4 pi epsilon naught is in 9 into 10 raised to power 9 into 3.2 into 10 raised to power minus 7 upon 15 into 10 raised to power minus 2. If I solve this, we'll get the value of electric field. So if we solve the basis of 10, so it will become 10 raised to power 9 into 10 raised to power minus 7 plus 2. So it will be 10 raised to power 4. Okay. So we have solved. Now we are left with 9 into 3.2 upon 15. On solving this, we'll get 12.8 into 10 raised to power 4. And if we want to write it, so we'll write it as 1.28 into 10 raised to power 5. If we multiply by 10 and divide by 10, so it will become 1.28 into 10 raised to power minus 5 Newton per coulomb. So the option A is the right answer, you can see here. So it's an easy question, just we have to put the values in the formula. If we move further, here's another question. A particle of mass m and charge q is placed at rest in the uniform electric field and then released. The kinetic energy attained by the particle after moving a distance y. Okay, so we have to find the kinetic energy of the charge which is released after putting in electric field. So it will move with the some kinetic energy, and we have to find the value of kinetic energy. So we know that kinetic energy, we can solve it by two methods. I will solve here by two methods. First is the kinetic energy is equals to work done. We know that the kinetic energy, change in kinetic work energy theorem stay there. The change in kinetic energy is equals to work done. So kinetic energy is work done. So what is the formula of work done? Force into displacement. We know that the formula is force into displacement. Okay. So here the distance is y, so the displacement will be y, and now we have to find the value of force. We know that the electric field is equals to force per unit charge. So what will be the value of force? It will be EQ. So if we put here, so the answer will be EQY. So I think option C is the right answer. And yeah, so now we'll solve it by another method. We can use another method here. So what will be the another method? We know that force is equals to mass into acceleration, but force is also is equals to EQ, we have seen here. So by equating, we get ma is equals to EQ. So if I get the value from here, EQ by m, so acceleration is EQ by m. Now we'll use the equation of motion. I hope you remember this equation of motion. V square minus u square is equals to 2as, where v is the final velocity, u is the initial velocity, a is the acceleration, s is the distance. So the distance here is y, so we'll put y. So it started from rest, so initial velocity will be 0 and the final velocity we have to find. So it will become the value of a is EQ by m into y. So we have to find the value of v. So the value of v square is 2EQY by m. But we have to find the value of kinetic energy. It's v square. We know that the kinetic energy is equals to half mv square. That is the formula of kinetic energy. So just we have to multiply both sides with half m. So it will be half mv square, half into m, 2EQY by m. So 2 m and m will cancel, we'll left with EQ and y. So you have seen I have solved with the both the methods. Whichever you find easy, you can do it by that. In this question, polar molecules are the molecules having zero dipole moment. First we'll understand what are polar molecules. So polar molecules are the molecules which have both positive and negative ions presented at separate distance. Okay, so each polar molecule will have a positive and negative ion separated by some distance. Okay, so obviously if there is a positive and negative charge separated by, that means this is a kind of dipole, and dipole has some moment, so this will have a dipole moment. Okay, so will this have a zero dipole moment? No, because it has charge as well as separated by distance. So the formula of dipole moment is q into 2a. So it also has charge, it is separated by some distance, so it cannot be 0. Acquire a dipole moment only in the presence of electric field due to the displacement of charge. Well, a dipolar molecule have a dipole moment. It does not acquire a dipole moment when it is placed in electric field. Okay, so that doesn't mean when you put this in electric field only then it will have a dipole moment. It already have a dipole moment. It's just in putting electric field, there must be some changes in their dipole moment, but it will not acquire at that time. It will be acquired previously. Okay, similarly third, so it will be another wrong. Acquire a dipole moment only when magnetic field is absent. If there is no magnetic field, only then it will require a dipole moment. No, it will have dipole moment, and obviously there will be effect of magnetic field on that polar molecule, but in the absence of dipole magnetic field there will be some dipole moment. It does not acquire at that time. Okay, so it is also another wrong statement. Having a permanent dipole moment, yes, it will have a permanent dipole moment, so that will be the right answer, because from the starting polar molecules have a certain dipole moment. Now if we move further, there is another question. An electric dipole moment of P is placed in an electric field of intensity. The dipole requires a position such that the axis of the dipole makes an angle theta with the direction of electric field. Let's suppose this is the direction of electric field. So we have placed some dipole here and it is making angle theta with it. Okay. Assuming that the potential energy of the dipole to be 0 when theta is 90. So theta is equals to 90 degree. So whenever this dipole is something like this, okay, so the dipole, if dipole is like this, it at that time the potential energy of that dipole is 0. And if dipole aligns with this electric field, then there will be some potential energy. We don't know how much, but there will be some potential energy. So it is given to us. Now we have to find the torque and potential energy of that dipole. Okay, so first we'll find the torque. What is the formula of torque? The formula of torque is tau is equals to, we know that it's P cross E. So here P E sine theta is the torque here. So as we can see, all the options have this, so we can't determine whether which is the right answer. We have to find the potential energy. So for the potential energy, what is the formula of potential energy? Is tau d theta. Okay, and the potential energy is 0 at 90 degree. That means at the value potential energy is 0 minimum when the theta is pi by 2, and the potential energy's value is maximum when the angle is 0. So we have the limits from pi by 2 to 0. Now we have to solve this integration. We know that if we invert this integration and invert the limit, we'll get a minus here. Okay, and what is the value of tau? Tau's value is Pe sine theta d theta. Now we know that P and E are constant, they will come out, and the integration of sine theta is cos theta. And if we put the limit here, pi by 2, upper limit minus lower limit, so the answer will be minus Pe upper limit minus lower limit. So we don't have to, it's cos theta. Okay, here it is theta. Okay, so there will be some angle, it will be theta, so it's minus Pe cos theta. So the answer will be A will be the right answer. Okay, now we'll move further. An electric dipole is placed at an angle of 30 degree with an electric field intensity. It experiences a torque equal to 4 Nm. Okay, and the charge on the dipole, if the dipole moment is 2 centimeter. For that we know that the formula of torque is Pe sine theta, and we know that the dipole moment is equals to charge into distance, that is 2a. Charge into distance between the charges of a dipole. So if the dipole length is 2a, So its dipole moment is like this. So if we put the values here, so it will become q into 2a into e sine theta. So we have given the value of theta here. So the theta is 30 degree, and the value of electric field intensity is also given 2 into 10 raised to power 5. Torque value is also given 4 Nm, and the value of dipole length, so that means dipole length here, it's not the value of a, it's the value of 2a. We have taken the dipole length from this point to this point is 2a, so the value of total dipole length will be not, this is not the value of a, this is the value of 2a. So it's equals to 2 centimeter, that means 10 raised to power minus 2 meter. So it's given. Now we'll put the values here. So we have to find the value of q. So the value of torque is 4. Q we have to find. 2's values is 2 into 10 raised to power minus 2, and electric field is 2 into 10 raised to power 5, and the sine 30. The value of sine 30, we all know that the value of sine 30 is 1 by 2. Q 2 into 10 raised to power minus 2 into 2 into 10 raised to power 5 into 1 by 2. So 1 by 2 is 2 cancel, 4 here, 4 2 cancel, the remaining is 2 is equals to q, and if the base is same, powers will be added. So the value of q will be 2 upon 10 raised to power 3. So the value of q is 2 into 10 raised to power minus 3 coulomb. So minus 3 is milli. B is the right answer. Okay, so now we'll move. So here's another question. A sphere enclosed an electric dipole with charge plus minus 3 into 10 to the power minus 6. What is the total electric flux? So we know that the formula of flux is charge enclosed upon epsilon naught, and the charge here is given. A sphere contain an electric dipole. एक sphere उसके अंदर एक electric dipole है, and the charge for positive side is 3 into 10 raised to power minus 6, and charge for negative side is minus 3 into 10 raised to power minus 6. So charge enclosed, so the total charge which is enclosed is 3 into 10 raised to power minus 6 minus 3 into 10 raised to power minus 6 plus and minus divided by epsilon naught. So as we can see here, these two terms are same, and they are with the minus sign, so they will eventually get cut and the answer will be 0. So the option B is the right answer. Okay, a hollow metal sphere of radius r is uniformly charged. The electric field due to the sphere at distance r at the center is given as. So to find it, we have to first remember that what are the values of, if we take the case of hollow sphere, what is the value of electric field. So in hollow sphere there are three cases arise. Like this is the hollow sphere, so it has some charge. We have to find the charge outer side, we have to find the charge inside and on the surface. We know that for hollow sphere the charge inside the charge is q by 4 pi epsilon naught r square, and here inside q is 0, so 0. For hollow sphere inside charge is 0, and on surface, as the distance is equals to the radius here, on the surface you can see from center to the surface distance is equals to the radius. So we can write here the electric field as q by 4 pi epsilon naught. Now we will replace this r with the radius of the sphere, and for the outer side Let's suppose this is the outer point and the distance of the point is smaller. So let's take it as 4 by 5 from epsilon naught, and the here will be, it will be r square. Okay, here it is r dash. Now what the question says, distance, how distance varies. Okay, 0 as r increases from r less than r and decreases r as r increases for greater than r. First we'll draw the graph of it to make it better understanding. So what happens when r is smaller than r? When r is smaller than r, so smaller r, so that means inside, so inside electric field is 0. So this is the value of r less than r. Okay, so at surface you can see, at the surface it is maximum. Okay, surface at this is maximum, and as we move away from the surface it will also start decreasing. Okay, so now what will happen, if we see 0 as r increases from less than r to r, I think this is also true, this is true, decreases as r increases greater than r. Obviously it's decreasing after r is greater than r, so this statement is true. Now if we move to second statement, as r increases from less than r, 0 as r, this is true, increases as r increases for, after r increases from greater r, if we moving outside, the electric field is decreasing, not increasing. So this is wrong statement. So decreases in the both the cases, this is also wrong because it's increasing from inside to surface. So increasing, so in the first case, from when we are moving from inside to the surface, this is increasing, so this is true for this case, but this is wrong when we move towards outer side, so this is another false statement. Now we'll move to the another question. Question number 13. A charge q is enclosed by a Gaussian surface of radius r. If the radius is double, the outward flux is given by will be reduced to half, remain the same, will be double, increase 4 times. So first we have to write the formula of flux. The flux is q by epsilon naught. This is enclosed charge, the charge which is enclosed in Gaussian surface. So if the radius is double, so here we can see the flux does not depend upon the radius. Flux does not depend, it will not reduce to half, it will not be doubled, it will not increase 40 times, because it is showing that it changes with radius, but flux does not depend upon radius, it only depends upon the charge it is enclosed, so it will remain same. So the option B is the right answer. Now we'll move further. So here's the question. The value of electric potential at a distance of 9 cm from point charge is, now we have to find the value of potential at a distance of 9 cm from the charge is this. So how we find it? First we'll have to write the value of distance. So here the distance is 9 cm. We can write it as 9 into 10 raised to the power minus 2 meter, and what is given, another thing is given, is charge. So the value of charge is 4 into 10 raised to the power minus 7 coulomb. Now we have to find the value of potential. So what is the formula? Formula of potential is kq by r. We know that it is the formula of potential, and the value of k is 9 into 10 raised to the power 9, and the value of q is 4 into 10 raised to the power minus 7 divided by 9 into 10 raised to the power minus 2, and 9, the 9 will get cancelled, and the remaining thing is 4 into, if we add the powers here, so it will be 4 into 10 raised to the power 4 volt. So option D is the right answer. You can see here, it's a very easy question. Now we'll move further. A 12 picofarad capacitor is connected to a 50-volt battery. The electrostatic energy stored in the capacitor in nanojoule is. Now here see, it's all about the units. You can see here the capacitance is given as 12 picofarad. We all know what is the picofarad value. It's 10 raised to power minus 12 farad. Okay, so we have given it, and we also have given the value of V, that is 50 volt. Now we have to find the energy. So we know that the formula of energy of a capacitor, half CV square, half, what is C here, 12 into 10 raised to power minus 12, and what is V here, 50. So we have put the values. Now we'll just cancel out. It will become 300 into 10 raised to power minus 12, 6, so it's square into 50, so it will be 15, 1, 2, 3 into 10 raised to power minus 12. So we can write it 3 zeros as 10 raised to power 3 into 10 raised to power minus 12. So it will become 15 into 10 raised to power minus 9 joule. Okay, so we have to find the answer in NJ. NJ means nanojoule. And what is nano? 10 raised to power minus 9. So we can write it as 15 NJ. So 15 NJ. So we have to find the NJ. So option A is the right answer. I hope you understood this. Now we'll move further. The capacitance of a capacitor with charge Q and potential difference V depends upon. So the formula of capacitance, to understand this we have to write the formula of capacitance. What is the formula of capacitance? That is epsilon naught A upon D. You know that this is the formula of capacitance. Does it depend upon both Q and V or Q or V? No, it does not depend upon V. It does not depend upon Q. It does not depend upon both Q and V. It is only depending upon the geometry. How? Like, which is depending on the area, it is depending upon the distance between the plates. So it's solely depending upon the geometry of the capacitor rather than charge or voltage. So I hope you understood how we got this answer. Now we'll move further. Here is another question. An electric dipole is placed at an angle of 30 degree. Okay, a dipole is placed at an angle of 30 degree. Here we have given the angle 30 degree. Now we have to find electric field is also given. Angle's value is 30 degree. Electric field is also given 2 into 10 raised to power 5 Newton per coulomb. Okay. Now another thing which is given, that is it experiences a torque tau, that is 4 Nm. We also have given the value of tau. Okay. Now another thing, calculate the magnitude of charge of the dipole if dipole length is 2 cm. 2 cm is the dipole length. We have done these questions previously also, but we'll do it by using this method. So E is equals to 2 into 10 raised to power 5 Newton per coulomb, and the length of the dipole is given as 2 centimeter. We can take it as 2 into 10 raised to power minus 2 meter. And now torque is also given 4 Nm. Now if we apply the formula, that is P E sine theta. Okay, so the value of P is Q into L, that is 2 into 10 raised to power minus 2, and value of E is 2 into 10 raised to power 5, and sine 30 is 1 by 2, and the value of tau is 4. So on solving, we will get the value of charge as 2 millicoulomb. We have already solved this question, so I again solved it for your convenience. Now if we move further, the next question says that the distance between two plates of parallel capacitor is doubled and area of each plate is halved. So the final capacitance of the capacitor will be equal to what? So the formula of capacitance is epsilon naught A upon D, and the distance, see, the plate capacitor doubled, the distance is doubled and area is halved. So if we halve the area and double the distance, this will be our new capacitance. So we denote new capacitance as C dash. So if we write here, you can see these two will get divided here, so it will become 4D, and this is nothing but C. So we can write C dash is equal to C by 4. So here we can see the new capacitance is equal to C by 4. So the option A is the right answer. Now we'll move further. The effective capacitance of two parallel plate capacitors is 3 microfarad and 16 microfarad when they are connected in series and parallel collectively. The capacitance of two capacitors is, okay, so we have given the effective capacitance when connected in series. So for series case it is 3 microfarad, and for parallel case it is 16 microfarad. Now we have to solve this question. How we'll solve it? We'll just use the formulas. We know that in parallel cases the capacitance directly added. So this is our equation 1. And for series it is 1 by C1 plus 1 by C2 is equal to 1 by C. So if we have to find the value of C, it will be C1 C2 upon C1 plus C2. Okay. Now this is another question, another equation. So here this is equal to 3 microfarad. And what is the value of C1 plus C2? That is 16. So C1, we can write C1 C2 is equal to 48 microfarad. Okay, so C1 is equal to 48 microfarad of C2. So we'll put the value of C1 in this equation. So what we will get? We will get it as 48 microfarad upon C2 plus C2 is equal to 16 microfarad. So it will become C2 square plus 16 C2 is equals plus 48. Okay, so it will be in minus plus 48 is equal to 0. So this is a quadratic equation. So the solution of this will be, if we try to solve it, so it will become 16 and the multiply it will get 48, so that will be 12. So the, if we divide it in factors, it will be minus 12 C2 minus 4 C2 plus 48 is equal to 0. So on solving we will get C1 minus 12 and C2 minus 12, C2 minus 12 and C2 minus 4. So the value of capacitance will be 12 and 4. Okay, so the capacitance will be 12 and 4. So the option D is the right answer. Now if we move further, two charged capacitors, spherical conductors of radius R1 and R2 are connected by a wire, and the ratio of surface charge density of the sphere is, so there is two conductors, let's suppose this two spherical conductor connected by a wire. The first radius is R1 and the second radius is R2, and this is a wire. Now spherical conductors are, if they are charged and connected, obviously if they are connected with the wire and they are charged, so the potential of this system will be constant, because they are connected with a metallical wire, so their potential will be constant. So the potential of this sphere will be equal to the potential of this sphere. So If we can write it as, what is the formula of potential? 1 by 4 pi epsilon naught Q by R1. So this is the charge on Q1. So similarly, this will be the charge on, this will be the potential value on another Q2 by R2. Okay. Now if I multiply this R1 by R2 and this by R2 by R2, we have multiplied by both sides, multiply and divide by both sides with R1 and R2 respectively. So this will become 1 by 4 pi R1 square Q R1 by epsilon naught. Similarly 1 by 4 pi R2 square Q2 R2 by epsilon naught. Okay, so we know that this is a spherical and the area, this can be the area of first body. So we can write it as Q1 R1 by epsilon naught A1, area of first body, because we know the sphere, area of sphere is 4 pi r square. So here again it is similar. Okay, but we know that Q by A is something else, is surface charge distribution. So it will become like sigma 1 R1 by epsilon naught. It will be sigma 2 R2 by epsilon naught will get cancelled. So sigma 1 by sigma 2 will be equal to R2 by R1. So we have to find the ratio of sigma 1 and sigma 2. So the answer is R2 by R1. So the option B is the right answer. Now we'll move further. Here's another question. Capacitor is charged by a battery. The capacitor removed and another identical uncharged capacitor is connected in parallel. The total electrostatic energy is, we have to find the total electrostatic energy. So first we'll see the arrangement here. So the arrangement says that there are two capacitors. Sorry, one capacitor here. And here is first battery. Okay, this is battery. So we have charged this capacitor. Let's suppose this is C1. And after charging it, we connected another capacitor parallel to it. Let's suppose that's C2. So we know that in parallel total capacitance is given by C1 plus C2. Okay. So now what we have to do? We have to find the first potential. What will be the potential in this circuit? So the potential in this circuit will be, what is the formula of potential? Potential formula is Q upon C. Okay. So what is Q here? Q is CV. We know that for the total, this is Q for total circuit. For the total circuit, there will be C into V, total potential into total capacitance. And what is total capacitance here? That is C1 plus C2. Okay. So in the parallel, if they have same capacitance, let's suppose CC. So the voltage after applying capacitor will be V by 2, and capacitance is C plus C, that is 2C. So the total capacitance is 2C and total voltage is V by 2. Now we have to find the energy. What is the formula of energy? Half CV square. Half, what is C? Here 2C, and what is V? V by 2 square. So 2 and 2 will get cancelled. So it will be CV by 4. CV square by 4. So the energy which came out is 1 by 4 CV square. But initial energy, that is half CV square. So from initial, the energy will get decreased by how much time? 2 times. So initial energy is U. It will get divided by 2, then we'll get the final energy. So that means energy got decreases by how much factor? 2 factors. So the option A is the right answer. Now we'll move further. This is another interesting question here. You can see here some diagrams are given and we have to find the a positive charge removal in all the four cases of work done. We have to find the basically the work done. So whether the work done will be same or minimum or maximum in figures. Okay, so what is work done basically? So if you remember in potential, we have discussed that work done is equals to change in potential, okay, VB minus VA. If you remember, work done is VB minus VA, work done if you have a point charge. Okay, so if we see the potential here, so there is no change in potential. Okay, there is no change in potential here. This is 10 volt, this is 20, this is 30, this is 40. So the difference is, see, the difference is common of 10 volt. So in first case the difference is 10 volt. In second case you will see the difference is again 10 volt. In third case you will see the difference is again 10 volt. In fourth case you will see the difference is again 10 volt. So what you have seen, the work done, if the difference of potential is same throughout the cases, in every case it is 10 10 10 10 10. So 10q 10q 10q. Okay, so will the work done will be changed? No, the work done is same for all the cases. That means the work done will remain constant in all the cases. Okay, so that was about it. Now we'll move further to another question. It says that A, B, C are the 3 points in a uniform electric field. The electric potential of which point is maximum or minimum? Okay, so how will we find the electric potential? So electric field, how electric field moves from positive to negative. So electric field lines always move positive to negative. But when we move to positive to negative, electric fields should always move in this direction. But from when we move from positive to negative, the potential will always decrease. You know that even in the circuit, when we move from positive to negative, the potential will decrease. So that means if electric field in the direction of electric field, potential will always be decrease. So if potential decreases, that means whichever point is near to the electric field direction will have the lowest potential. So maximum potential will have B. So B will have the maximum potential. Okay, so what will be the pattern? So pattern will be the potential of B will be the maximum, then potential of C, because it is less close than A, and the potential of A will be the lesser than C and B of B. Okay, now we'll move to another question. So here's another question. 4-point charges minus q, small q, plus 2q and q are placed one of each corner of the square. Okay, so there is a square and 4 charges minus q, plus 2q and 2q. Our relation between potential at the center of square is 0. Okay, so we have to find the relation between them if at the center the potential is 0. At the center potential is 0. If at the center potential is 0, okay, so the net potential, first we have to find the net potential for each charge. Okay, so let's suppose this is O. Okay, this is A, B, C, D. We know that AC and BD will have same magnitude. How much? If side of this square is A, that means A square plus A square, that is 2A square. Okay, so it will be A square if we have to find the AC, and A square, so it will be this according to Pythagoras theorem. Okay, so what is the value of AC or BD? It will be same, root 2A. Okay, so we have found the value of AC. If we have found the value of AC and this is a square, according to geometry, if we divide this diagonal into half, we will get this distance, and this is same from all side. So that means for AO, OC, OB and OD, so if we divide this by 2, we'll get the distance of each point, that will be A by root 2. So this is the distance from center for each point. And now if we write the potential, so what will be the potential of our sum? According to principle of superposition, total potential will be like this, minus q upon, okay, first charge is minus q upon distance, that is A by root 2. Second is minus q upon A by root 2. Third is 2q by A by root 2. Fourth is plus 2q by A by root 2. And this is equal to 0 given. Now the lower terms will get to 0 and the minus q plus 2q will give us q, and plus 2q and minus q will give us q is equal to 0. So q will be equal to minus of q. According to this, q will be equal to minus 2. Okay, so the option A will be the right answer. So our q charge will be equal to minus q. Very good. So here's the last question, and this is the last question of this chapter. And what it say, a hollow cylindrical has a charge q coulomb with it. If phi is the electric flux in the unit of volt, then curved surface B flux linked with the plane surface A unit V will be equal to what? So we have to find the flux here. How can we find the flux? So first we have to apply, what is flux? Q by epsilon naught. We know this is the formula of flux, and here there are 3 points A, B and C. So we have to find the flux for all 3 points, phi A, phi B and phi C. But you will see A and C in this figure are at, basically they are same because they are on covering equal area, or they are almost similar regions. They are just different names. That means Q, the flux will be same for both these identities because they have equal area, so flux will be same. Although the flux of B is not same to C, flux of A will be equal to flux of C. So A and C have same flux. Now this is our first condition. Now we have to find the total flux. How can we find the total flux? We'll sum these 3 fluxes. And how much it will be equal to? Q by epsilon naught. We know that phi A is equal to phi C. So we can write phi A as phi C. So here you can see this can be added. So it will become 2 phi C is equal to Q by epsilon naught. And phi V will be equal to Q by epsilon naught minus, okay, so phi V, what will be the phi B here? Phi B are flux, so we can write phi B as phi, okay, because curved surface area's flux is phi, it is given. So the curved surface area flux is phi, so curved surface area is represented by phi B, so we can write it as phi. So 2 phi C will be equal to Q by epsilon naught minus phi, and the flux for other region will be 1 by 2 Q by epsilon naught minus phi. So that is our option number D. So here you can see how we have found the flux. So that is all for this chapter. We have discussed almost 25 numericals for this chapter. I hope you have got the basic understanding of this chapter. We have almost used every formula which is being used in this, and we have discussed previous year questions also. So I hope you have learned something new today. Thank you so much for watching. Have a nice day.